Welcome back to Data with Srinivas. We are now in lesson 9 of SQL Fundamentals, and today we are learning one of the most useful techniques for making professional SQL easier to read, the Common Table Expression or CTE. Let's begin with a business question. We have already seen which providers have total claim amounts above the average provider total. In lesson 7 on subqueries, we learned how one query can provide information another query needs. That solution worked. But as SQL problems become larger, we also need to think about something beyond simply getting the correct answer. We need to ask, can another developer understand this query quickly? Can I debug it 6 months from now? Can I explain each business step to an analyst or a manager? That is where CTEs become extremely valuable. Look at the flow on the right. Step 1, calculate provided totals. Step 2, calculate or compare against the average. Step 3, return the providers that satisfy the business rule. A CTE, let us give an intermediate result a meaningful name. Instead of thinking about one giant SQL statement, we can think it in business steps. First, prepare provided totals, then use those totals for the next calculation. Finally, return the business answer. The core mental model for this lesson is CTE is equal to a named intermediate result that helps us organize SQL. By the end of this lesson, you will understand what a CTE is, why developers use it, how its scope works, how it compares with a subquery and a view, how multiple CTEs can form a readable pipeline, and why CTEs are frequently paired with window functions. And that last point is important because lesson 10 will be our introduction to window functions. So think of lesson 9 as the bridge from writing SQL that works to writing SQL that is easier to understand and extend. Before looking at syntax, let us understand the problem CTE solves. On the left, imagine a query containing nested logic inside more nested logic. Technically, the SQL may be correct, but the correct SQL is not automatically good SQL. When business logic is buried several levels deep, a developer may have to repeatedly ask, what does this inner query return? Why is this calculation here? Which result is the next query using? Where should I troubleshoot if the result looks wrong? That cognitive load grows quickly. Now look at the right side. With CTE, we can take an important intermediate result and give it a business-friendly name. For example, step 1, build provider totals. Step 2, give that result the name provider totals. Step 3, query provider totals in the statement that follows. That name becomes documentation inside the SQL. If I see a CTE called provider totals, I already have a strong clue about what the result represents. This gives us three major benefits. First, readability. The query tells a story in steps. Second, maintainability. If the business rule changes, we can identify the logical section more easily. Third, troubleshooting. We can isolate and test the logic that produces each result. One important clarification, do not learn CTE means faster SQL. CTE is not automatically a performance optimization. SQL Server Optimizer decides how to execute the overall statement, and equivalent SQL written with a CTE, derived table, or subquery may sometimes produce similar execution plans. For this fundamental lesson, the main reason to use CTE is clarity. Professional takeaway, the best SQL is not merely SQL that runs. It should also communicate the business logic clearly to the next person who reads it. CTE stands for Common Table Expression, as we already discussed. That name sounds more complicated than the idea. CTE is named result set defined inside a SQL statement. We normally begin with the with keyword. For example, with provider totals as. Inside the parentheses, we write the query that produces the result we want to name. Then the statement immediately following the CTE can reference provided total almost as if it were a table. That's why CTEs are so readable. Instead of repeatedly starting at complicated calculation, the main query can work with a meaningful name. But there are three things I do not want you to confuse. A CTE is not a permanent table. A CTE is not a view saved in the database. And CTE is not automatically materialized as separate stored copy of the data. For our beginner mental model, think of it as a temporary name for a query result that is available to the statement that follows. This defines and names the intermediate result. This conjunes that named result. You may hear people casually call it as a CTE, temporary result. That is fine as a learning description as long as we remember that it is not the same thing as creating a SQL Server temporary table such as hash provided totals. Later, when we study performance tuning, we will learn why that distinction matters. For now, remember CTE is equal to name a useful query result so the next statement can use it clearly. Now let us translate concept into syntax. The general pattern is with CTE name as open parenthesis, your select query, close parenthesis. Then the statement that uses CTE. Let us break that down. First, with tells SQL that we are defining a common table expression. Second, CTE underscore name is the name we choose for the result. Choose a name that describes a business meaning. Provided totals is better than something vague like CTE1. Third, as followed by parenthesis, contains the query that gives the result. That query can use many SQL concepts we already know: joins, where, group by, having, case when, and even other appropriate query logic. Fourth, next statement references the CTE name. Usually in our example, that will be a select, but a CTE can also be used with other supported statements such as insert, update, delete, or merge in SQL Server. We are staying with select because this is the SQL Fundamentals course. There is also a SQL Server habit. You will often see semicolon with written as semicolon WITH. Why? With can appear in other SQL syntax. If previous statement in the batch was not terminated properly, SQL Server can become confused. The formal solution is to terminate SQL statement correctly with semicolons. Many SQL Server developers also write semicolon with defensively so the previous statement is clearly terminated. For this course, the important thing is not to memorize a trick, understand the structure, define the name and result, then immediately use it. Professional habit. Before writing a CTE, ask yourself, what business result am I naming? If you can answer that in plain English, you can usually choose a good CTE name. Now let us use our healthcare database. We want one row per provider with that provider's total claim amount. We already know how to write the underlying aggregation. Select provider ID, sum of claim amount as provider total from claims, group by provider ID. The CTA does not replace that SQL, it organizes it. We place that familiar query inside with provider totals as open parenthesis, close parenthesis. Now we have given the result a meaningful name, provider totals. Then the main query says select star from provider totals. Read this in English. First, calculate total claim amount for each provider. Second, call that result provider total. Third, use provider totals in the next statement. This is the major SQL learning milestone. Instead of reading only syntax, begin translating SQL into business steps. If a business analyst asks what this query does, we should be able to explain it without reading every comma and parenthesis. We first calculate provider totals, then we query those totals. That is much easier to communicate. Also notice that CTE name represents the green of the intermediate result. A claims table may contain many rows per provider. After group by, provider totals contain one row per provider. That grain awareness becomes extremely important when we later combine CTEs with join and window functions. So another professional question to ask is, what does one row represent at this stage of my query? Because we just completed subqueries in lesson 7, this comparison is important. A subquery and CTE can sometimes solve the same business problem. So, which one should you use? Start with the structure. A subquery is nested inside the another query. A CTE is defined first, given a name, and then referenced by the statement that follows. For a short calculation, a subquery can be very compact and perfectly readable. For example, comparing a value against one average written by a scalar subquery may be simple enough that a CTE would add unnecessary structure. But when the intermediate result is important, reused within the statement, or represent a clear business step, CTE can make the logic easier to follow. Think is that way. Subquery mental model. I need a query inside this part of another query. CTE mental model. I want to prepare and name this result before I use it. Neither is automatically better and neither is automatically faster. SQL Server may transform and optimize logically equivalent forms. Your first station should be correctness. Your second should be clarity and maintainability. Then, for the performance sensitive production SQL, you inspect the actual execution plan, I/O, runtime behavior, indexes, and data volume rather than assuming one syntax is faster. This is also a good place to connect to views. A view is saved as a database object for use across statements and sessions. A CT is local to the statement that follows. A subquery is embedded within another query. So we now have three different ways to organize logic. Subquery, nested logic; CTE, named statement level logic; view, saved, reusable database logic. Understanding that distinction gives you much broader SQL horizon than simply memorizing with. This slide contains one of the most important CTE rules. A CTE name is available to the single statement that immediately follows the CTE definition. Look at the flow. First, we define provider totals. Second, the next select can reference provider totals. After that statement finishes, we cannot write another independent select and expect provider totals still exist. It is out of scope. That is very different from view. If we create a view called VW provider claim summary, that view remains a database object until it is changed or dropped. It is also different from a temporary table. If we create hash provider totals, that a temporary table can generally be referenced by multiple statements during its applicable session or scope. The CT is much more narrower. Define it, use it in the next statement. Then its name is gone. This narrow scope is not a weakness. It tells us what a CTE is designed for, organizing one SQL statement. Also remember that temporary here describes the name and scope. It does not mean SQL Server necessarily creates a physical temporary table behind the scenes. That's a common misconception. If a CTE is referenced more than once in a query, do not automatically assume SQL Server calculated it once and stored the result for free reuse. The optimizer decides the execution strategy. For performance critical cases, where you truly need to persist and index an intermediate result, a temporary table may sometimes be more appropriate design. That is beyond our fundamentals implementation. But I wanted to know the horizon. For today, CTE scope is equal to the statement immediately following it. One CTE useful. Multiple CTEs can make multi-step business problem read almost like a workflow. Imagine our provider analysis. Step 1, provider totals calculates total claim amount per provider. Step 2, another CTE could calculate a benchmark or prepare another business result. Step 3, another named step could identify above average providers. Step 4, the final select returns the report. That is the pipeline mindset. In SQL Server, when defining multiple CTEs for the same statement, we normally use one with keyword and separate CTE definitions with comma. Conceptually, with first CTE as, second CTE as, third CTE as, select from the third CTE. A later CTE can reference an earlier CTE in the same with chain, which allows us to build logic progressively. This is extremely useful when a business problem naturally has steps or stages. For example, eligible members, then high risk members, then provider assignments, then final outreach list. Those names can make complicated healthcare analytics far easier to review than one deeply nested block. But there is also a balance. Do not create 10 CTEs just because you can. Each CTE should represent a meaningful transformation or a business step. If the names do not clarify the logic, the structure is not helping. Professional habit. Design your CTE names like section headings in a document. The reader should be able to scan the names and understand the flow of the analysis before reading every line of the SQL. This slide shows why I wanted CTEs before window functions in our fundamental sequence. Look at the first step. The CTE called provider totals aggregates the claims table. After group by, we have one row per provider, provider ID dot provider total. That gives us clean provider level data set. Now look at the outer select. We keep provider ID and provider total, but we add rank over order by provider total descending. Do not worry if rank syntax is new. That is lesson 10. The important idea today is division of responsibility. CTE prepares the data set. The window function analyzes the prepared rows. CTE is equal to organize. Window function is equal to analyze. This pattern appears constantly in real analytics SQL. For example, a CTE may first calculate monthly member spend, and window function may rank members within each region. A CTE may first calculate provider claims total, and a window function may rank providers. CTE may first prepare one row per member per month, and lag may compare the current month with the previous month. This is why CTEs are not just another syntax topic. They become part of how we structure analytical thinking. Also notice the grain again. The CTE changes the claims level data into provider level totals. The rank operates over those provider level totals. Understanding the grain before applying window function prevents many analytical mistakes. So as we move into lesson 10, remember, prepare the correct data set first, then apply the analytical window function. That is a production quality habit. Let us cover the mistakes that cause the most confusion. Mistake 1. Defining a CTE without a statement that conjunes set. A CTE cannot simply sit by itself with provided totals as must be followed by the statement that uses provided totals. Mistake 2. Trying to reuse the same CTE in a later independent statement. Remember the scope rule. The CTE name belongs to the next statement only. If several separate queries need the same logic, consider whether a view, a temporary table, stored procedure, or another design is more appropriate. Mistake 3. Assuming a CTE automatically makes SQL faster. It does not. CTE syntax primarily gives us a way to organize the query. For performance measure, look at the execution plan, look at the logical reads, look at indexes, look at row counts, look at whether predicates are selective, look at whether large intermediate work is being repeated. Never choose syntax based on the performance myth. Mistake 4. Creating one enormous CTE and calling the query readable. A CTE helps only if the structure communicates the business logic. If one CTE contains hundreds of lines mixing unrelated responsibilities, the name alone does not solve the design problem. There are two additional professional issues worth knowing. First, naming. Avoid names such as CTE1, CTE2, or temp data, and a business name is available. Prefer names such as provider totals, high risk members, latest claim, or eligible members. Second, recursive CTEs. CTEs can also reference themselves and solve hierarchical or recursive problems such as organizational trees, category hierarchies, or sequence generation. That is called recursive CTE. We are intentionally not teaching recursive CTEs in this fundamental lesson because they deserve their own explanation. But I want you to know that the CTE concept goes beyond the non-recursive examples we are using today. Fundamental goal, master readable non-recursive CTEs first. Now it's your turn. The business request is create a CTE named provider total, then return only providers whose total claim amount is greater than $50,000. Required output, provider ID and provider total. Let us think through the problem without immediately writing the solution. What should the CTE do? The name tells provider total should calculate one total per provider. So inside the CTE, we need provider ID, sum of the claim amount, and group by provider ID. What should the outer query do? Outer query should work with the already prepared provider totals result and keep only provider total greater than 50,000. Notice how cleanly the responsibility is separate. CTE prepare the provider level dataset. Outer query applies the final business filter and return the answer. This is different from having only in terms of the learning objective. As this particular business result could be written more directly with group by and having. We are intentionally using CTE here to practice the CTE pattern and make the intermediate provider totals reusable within the statement. That is an important professional lesson. SQL often gives you multiple correct ways to solve the same problem. Your job is to choose the form that makes the logic clear for the situation. Pause the video now and try it in SSMS, that's the SQL Server Management Studio, when you are ready to continue the solution. Let us review the solution. We begin with provider totals as. Inside the CTE, we select provider ID and sum of the claim amount as a provider total. We group by provider ID. At this stage, our intermediate result has one row per provider. Then outer query selects provider ID and provider total from provider totals. The where clause keeps only rows where provider total is greater than 50,000. Finally, order by provider total descending places the highest totals first. Now let us summarize this lesson. Number 1, CTE stands for Common Table Expression. Number 2, a CTE gives a meaningful name to an intermediate query result. Number 3, its scope is the statement that immediately follows it. Number 4, CTEs are excellent for organizing multi-step SQL and making business logic easier to read, debug, explain, and maintain. Number 5, a CTE is not automatically faster than a subquery, and it is not the same thing as a view or a temporary table. And number 6, our bridge forward. CTEs pair naturally with the window functions. The mental model I want you to leave with is subquery, nest a query where another query needs it. View, save reusable query logic as a database object. CTE, name and organize intermediate logic inside a statement. Window function, analyze rows while retaining the detail needed for analytics. That gives as much broader SQL toolbox. In lesson 10, we'll complete SQL fundamentals with an introduction to window functions. We'll see how over, partition by, ranking, and analytical calculations let us answer the question that group by alone cannot answer without collapsing the rows. And because window functions are such an important topic, the fundamental lesson will give you the foundation and connect naturally to the D for window function series. Final takeaway. Do not use a CTE simply because professional SQL contains with. Use a CTE when naming an intermediate result makes the business logic easier to understand. Readable SQL is not cosmetic. Readable SQL is easier to validate, easier to maintain, easier to hand off, and safer to change. That is the professional value of CTEs.